Let's have a look at the sine and cosine rules. Notice I've put rules in quotes because a rule is something you make up, like drive on the left. And these sine and cosine rules are not rules at all. They're just consequences of sine and cosine being what they are. So it's a real abuse of language to call them rules. But that is what they're known as, so sine and cosine rules. Let's start with the sine rule. And that says if you have some triangle then if that's A and that's alpha and that's B and that's beta and that's C and that's gamma, then sine alpha over A equals sine beta over B equals sine gamma over C. If you'd like to, pause the video and see if you can figure it out. Here's a hint. The important construction step is to drop a perpendicular, making two right-angled triangles. So now that gives us a height h, and let's split C into P and Q. Okay, so we've got sine of alpha is opposite over hypotenuse. And we've got sine beta is opposite over hypotenuse. And so we can write h as b sine alpha or a sine beta. Yeah? B sine alpha equals h, a sine beta equals h. So b sine alpha equals a sine beta. Divide both sides by AB. And we get sine alpha over A equals sine beta over B. Which means we're done. Okay, it turns out we didn't actually need P and Q. We didn't even need to involve side C at all. So I could put that in brackets and that angle in brackets. because we didn't say which two sides we chose. So we could have chosen this one and proved it, or this one and this one, or this one and this one, and regardless of which sides we choose, it's going to be the same result. So bracket equals sine gamma over c by symmetry. So we should probably relocate our done box to there. Okay, this is known as the sine rule. Now let's look at another challenge. Suppose you've got two sides of a triangle and you've got the angle. So that's A and B, and you've got the angle, and you wish to find this third length, x. This is going to be the cosine rule. This is how we motivate it. So you've got two sides of a triangle and you've got one and the angle between them, and you need the other side's length. So the nicest way to prove it is using vectors. So let's rotate our triangle so one of these sides is flat along the x-axis. Doesn't matter which one. I might as well relabel these just so I can have A being flat along the axis. It kind of sounds better. So there's our A. So this point here is the vector, well, it's A in the x direction, 0 in the y direction. And this vector is what? Well, it's got a length of b and an angle of theta. So its coordinates are going to be, well, imagine if it was of length 1, then it would be on the unit circle. That's an angle theta. So therefore it would be cos theta sine theta. But it has length b, so it's b cos theta b sine theta. And we need the length of this vector x. I could draw it either direction. I'll draw it from A to B, that makes most sense. And this vector x is equal to, well, from here to here is from here to here, which is minus a, plus from here to here, which is plus that. So minus a naught plus b cos theta b sine theta. So let's use Pythagoras to get the square of this length. Which is just the square of the x component, which is minus a plus b cos theta, plus the square of the y component, which is 0 plus b sine theta, which is minus a plus b cos theta minus a plus b cos theta. That's a squared. That's minus ab cos theta. There's another minus ab cos theta here. And we've got a b squared cos squared theta here. Notice we don't write cos theta squared because that would suggest we're squaring the theta, and we're not. We're squaring the cos theta. Hopefully you're happy with b cos theta squared being b squared cos squared theta. Like if I've got 2 times 3 and I square it, that's 2 squared times 3 squared. Yeah, 36. So we have a squared minus 2ab cos theta plus b squared cos squared theta plus b squared sine squared theta. So it's that thing plus b squared cos squared theta plus sine squared theta. I can just write c squared plus s squared, because we know from our unit circle and sine and cos that that length is 1, so that squared plus that squared equals 1. Cos theta sine theta. So that is 1. So it's equal to a squared minus 2ab cos theta plus b squared. Yeah, so if we give this a x vector has a length of x. So we get x squared equals a squared plus b squared minus 2ab cos theta. And this is the cosine rule. What happens when theta is 90 degrees? A, B, x. Well, it's going to be x squared equals a squared plus b squared minus 2ab. Well, what's cos of 90 degrees? There's our theta, which is a right angle. Cos of 90 degrees, when we are 90 degrees around the circle, what's the x component? It's 0. So cos 90 degrees. And that disappears, and it leaves us with Pythagoras. Which of course it should. Notice you shouldn't be saying Pythagoras is just a special case of the cosine rule, because we used Pythagoras in order to get the cosine rule. It's just an observation that everything makes sense when we have a right angle triangle. Okay, done.